Carboxylic acids have the generic formula with a COOH connected to some kind of alkyl group. And COOH consists of a carbonyl, a C double bond O, connected to an OH group. So it's like a carbonyl with an alcohol next to it, and then there'll be some type of alkyl thing to the other side. This is a special kind of a reactivity. The hydrogen on the end of the OH is actually slightly acidic. That's why it's an acid. Carboxylic acids are all weak acids. They're not very strong, all right? But they are really important. A lot of them are in common things around us. An example that's rotating right there, there are 3 carbons, and it's a carboxylic acid because it has a C double bond O and the OH on the end. If it was an alkane, it would be propane, but because it's a carboxylic acid, you take off the E and add oic acid, propanoic acid. The carbon number 1 is always the carboxylic acid. So the carbon with the oxygen and the OH on it, that would be number 1, 2, 3, etc., etc. Formic acid is the simplest carboxylic acid where you have just a hydrogen next to the COOH. Formic acid is another type of carboxylic acid. Acetic acid is a compound we've run into here and there, and it's related to the acetate polyatomic ion. And maybe now you can see why it's listed as so many ways. Acetic acid is a common name for ethanoic acid. Ethanoic acid means 2 carbons, and those are the 2 carbons right there. And those 2 carbons, there's a C double bond O. This is the double bond O, and the OH. So instead of calling it ethanoic acid, most people will call it acetic acid, which is fine, whatever. But anyway, because it's acidic, the hydrogen on the end right there will a lot of times pop off. And if you look at the rest of that molecule, you've got a CH3 followed by a CO2. So acetate and acetic acid are related to each other. Acetate is CH3CO2 -1, and acetic acid has the hydrogen on the end of it. So this is the joy, and this is why the acetate ion is so weird to talk about. Like, do you write it CH3CO2 minus? Do you call it C2H3O2 -1? There's a whole bunch of different ways to write acetate, and now you can understand some of the confusion around it. Now, benzoic acid on the right is a benzene ring, C6H6, but one of the hydrogens was pulled off, and you're putting that C double bond OOH off of it. And again, like acetic acid, that hydrogen is acidic. It pops off. It makes what's called the benzoate ion. We'll talk about that more in Chem 223. But again, the important part here is that all these carboxylic acids, that hydrogen next to the O is slightly acidic. When the hydrogen as H plus plops off, you have an O -1, and the double bond O, it'll resonate back and forth. So the O -1 can kind of go back and forth between the oxygens. It provides a little bit of stability. And the same thing with acetic acid. These acids are found in lots of natural substances. A lot of the things we eat actually have slightly acidic parts. Our bodies are used to things that are a little bit acidic. Vinegar is actually basically just acetic acid. All right, they'll put other kinds of spices and stuff in it to give it different flavors, but basically the ingredient of vinegar is just acetic acid. It's a pretty dilute acetic acid. You can buy much more concentrated ones in a chemistry lab, but it's still kind of cool. Yeah, put some acetic acid on your salad, i.e. some vinegar. Okay, getting too excited here. Formic acid is, again, the simplest of ones. If you've ever been stung by an ant, that's what they use to make the sting part. So it's pretty powerful stuff. Aspirin is another type of a weak acid. The part right up there has a little bit of an OH on it. Acetylsalicylic acid is the technical name for it, which you'll learn more about in organic chemistry. Notice that down here we've got a C double bond OO, but it's not an acid. That's another kind of a compound with a benzene ring in the middle. So you can see how this stuff can get pretty crazy. But again, we're just putting our, big toe in the water here, getting a feel for what it's like. And then in the actual organic chemistry class, you'll be able to rock this stuff. Let's name this compound, all right? And again, longest chain, smallest number, identify the family, all that kind of stuff. All right. So by this time, you can probably see we got to count the number of carbons. There are 1, 2, 3, 4, 5 carbons, all right? So it's going to be pent something. So answer A is flat out. This thing has a carbonyl, a C double bond O, so it might be tempting to think it's a ketone or something, but it's not. This carbonyl has an OH next to it. So it's not an alcohol, doesn't have an OL ending. It's not a ketone, ONE. It's not an aldehyde, AL. If you have a carbonyl, a C double bond O next to an OH, this is a carboxylic acid. And because there are 5 carbons next to it, this is going to be called pentanoic acid. 5 carbons, carboxylic acid, you're good to go. Butanoic acid would have only 4 carbons, not 5 total. The carbon with the carbonyl, the carboxylic acid group does count, by the way. Pretty chill. The last family of compounds that I want you to know for Chem 222 is what they call an amine. And while a carboxylic acid is a weak acid, an amine is the equivalent but weak base. And acids and bases, sometimes we use them for energy sources, so amines are also really important. Amines have a nitrogen. This is the first time we've seen nitrogen in these compounds. The nitrogens here are sp3 tetrahedral, but the nitrogens do have a lone pair on them, and I want you to remember that. So because of the lone pair on the nitrogen, there are 3 spots left. You can have all 3 spots as alkyl groups, R. You could also have all 3 as hydrogens. If you have all 3 as hydrogens, then in that generic formula, X is 3, and R, 3 minus 3 would be 0. You wouldn't have any alkyl groups. On the other hand, you can have all the groups alkyl, so you'd have 0 for X, you'd have 3 alkyl groups off a nitrogen, etc., etc. Naming these for us is not usually too bad. If you have an ethyl group connected to a nitrogen and 2 other hydrogens, this becomes ethylamine. So the CH3CH2 is the ethyl group. It's connected to the nitrogen, which is an amine. No problem. Now, this is a single ethyl. You could also have a diethylamine. So if you took off one of the hydrogens in H2 there, you could have 2 ethyl groups, a nitrogen, and 1 hydrogen for diethylamine. But you could take all the hydrogens off, put 3 ethyl groups next to the nitrogen, you'd have triethylamine. So you can hopefully see how this stuff kind of works out. So let's name this compound, all right? And you can see there that there are 2 methyl groups, 2 CH3s. They're connected to a nitrogen with 1 hydrogen. So things connected to a nitrogen are amines. The methyl group, there's 2 of them, so it's dimethyl, all right? It's going to be dimethyl something. If you look through this list here, that some of them are kind of funny sounding, but dimethyl nitro, that doesn't make any sense. Dinitrate sounds cool, but that doesn't make any sense either. This one is definitely going to be dimethylamine, 2 methyl groups off the nitrogen. And of course, you could have trimethylamine, which would be 3 methyls and no hydrogens. If you have all hydrogens, that's ammonia, NH3, which is the simplest one. The other answer is methylated nitrane doesn't make any sense, and Drano is essentially sodium hydroxide. That doesn't count either. So here's the methylamine, dimethylamine, and trimethylamine list of families. And again, the blue atom there is the nitrogen, and on top you're going to have a lone pair. So like carbon, nitrogen wants to have 4 groups around it, so you're going to have 3 positions for connections to atoms. And as you take off the hydrogens and add methyl groups, you can see in the last one they're all gone, but you still have that lone pair on it. Amines generally have really bad smells, and boy, oh boy, like ammonia has kind of a powerful smell, like in smelling salts, but the other amines, in my opinion, are just horrible sounding, and they're really funky. But anyway, cadaverine smells like a cadaver. That's actually a diamine. There's 2 amine groups on it. And pyridine, man, that stuff is really funky. This is kind of strange, but Viagra has a certain effect on men. Pyridine would be the anti-Viagra. It does the opposite thing. So pyridine is one I always tried to stay away from because, well, I'm a human being and I'm male and I don't want to have the anti-Viagra effect happen on me, shall we say. So be careful, people, if you're around pyridine. I would, anyway, it's a long story. You've been warned. All right, just say no, whatever.
To visually reinforce the fact that members of a homologous series, such as we see here, differ from each other by a specific structural unit, we use molecular models. Here, for instance, is the tetrahedron of carbon, a model of methane. In order to turn that model into ethane, we add another CH3 group to the end by substituting for a hydrogen. If we wanted to go from a propane to an ethane, we would remove that specific member of the homologous series, a CH2 group. Reconnecting the carbon atoms, then we're back to our ethane. Models can be used that are commercially available, but if they're not available, gumdrops work just as well.
If you are planning on taking the year-long organic chemistry course after the Chem 221 through Chem 223 series, I really highly recommend to the strongest degree possible that you buy a model kit. You're going to see that there's so many changes that happen with the geometry, and we haven't talked about all the types of isomers that are possible in organic chemistry, but having a model kit is really important. A good model kit will do not just single bonds, but also double bonds, so you can see cis and trans. They'll do triple bonds and all kinds of cool things. So again, if you're going to take organic chemistry, the year-long class, you really, really need a model kit. You can use gumdrops, absolutely. All right, little gumdrops and little toothpicks and stuff. However, my problem was as I was studying, trying to use gumdrops, and I'd start eating all the gumdrops. Gummy bears work as well, but again, those went down as easily as gumdrops. So I didn't eat my model kit. That's what helped me. But anyway, that's my personal problem and not yours. But anyway, if you take OChem, you should absolutely get a model kit. They're pretty cool.